Hey guys, Buildzoid here, and today we're going to be taking a look at Gigabyte's X299 Gaming 9 motherboard. So this is the top of the line board from Gigabyte for X299. As of right now, there is rumors that there might be a second wave of motherboards for like the 18 core and such. But as of right now, this is definitely the top board that you can get from Gigabyte. So, and interestingly enough, it also shares a lot of the VRM design with some of the lower end boards, so I'm pretty sure for like the Gaming 7, basically everything I say here is relevant for that board as well. As far as the VRMs are concerned, the features are different, but the VRMs stay the same pretty far down the Gigabyte motherboard stack for X299.
Before getting to that, this coverage is brought to you by our 10-year anniversary edition shirt, which has an explosion design layout on the front. The shirt comes in both teal and gray with tri-blend and cotton materials and celebrates the 10th year since we started designing GamersNexus.net, ultimately leading to its launch about 9.5 years ago. You can go to gamersnexus.squarespace.com to pick up one of the shirts.
So, before we get to the VRMs, I'll just point out some interesting features that the board has. It has a power button right there, reset button right there, clear BIOS over here, postcode down here, which I'm personally not a fan of, because if you put, well, they don't have the right spacing for 4-way, do they? Nope, it doesn't. So it's not really an issue, but if you were running a multi-GPU setup, there is a chance that you might end up covering the postcode and then you can't see it, and that's annoying, to say the least. So I don't really, and actually same goes for the buttons, so this low positioning for these things that you need to access is really less than ideal if you're running a multi-GPU setup, but those are super rare these days, so it's not really a huge issue for most people. And the board does have dual BIOS, though I can't actually point out where the BIOS chips are, because you can sort of see one of them here, but I haven't managed to find the other one. But it does have Gigabyte's dual BIOS, so if you are flashing the BIOS on the board and something goes really, really wrong, you're still not actually, like, you don't really have a problem, because the dual BIOS will recover from that really, really easily. So yeah, that's a nice feature to have on a board, and Gigabyte puts it basically on almost every board they make. So that's standard Gigabyte right there. Now then, let's start taking a look at the actual VRMs, starting with the biggest and most important one, the VCCIN, or also known as vCore VRM. And this is a problem caused by the fact that X299 uses two completely different architectures, so to speak, dies. So you have Skylake X, which has a fiver, and then you have Kaby Lake X, which doesn't have a fiver. For those of you, and I'm not talking about the fiver coin, I'm talking about the fully integrated voltage regulator. And so basically that is a bit of circuitry built into the Skylake X CPUs, which takes a single voltage and converts it into all the other voltages the CPU needs internally. And it exists because it's a great way to save power on the motherboard VRM, because ultimately it is really, really hard to push a lot of current at low voltage. So the fiver basically takes a slightly higher voltage. It's still not straight 12 volts. It takes in, say, 1.8 to 2 volts, and it converts that down to VCore, VCCSA, VCCIO, any other voltages the CPU needs. It produces all of those off of a single voltage. So the VCCIN VRM does that. However, if you put in a Kaby Lake X CPU instead of a Skylake X, which if you're putting a Kaby Lake X CPU into this motherboard, you're probably doing something wrong, because this board costs way more than a Kaby Lake X chip does. So that's some weird priorities you have there. But if you put a Kaby Lake X CPU into this motherboard, what ends up happening is VCCIN is no longer VCCIN, it is now vCore. And the reason for that is because Kaby Lake X doesn't have the fully integrated voltage regulator, so it has to have all of its voltage supplied by them. All of its voltages supplied externally from the motherboard. So that's why you also have this phase right here, and then this VRM right here, and basically this is VCCSA, and this right here is VCCIO. those only run if you have a Kaby-Lake X CPU, because otherwise they don't need to exist. So yeah, Intel, you know, this is what happens when you shove a Kaby-Lake die, because that's ultimately what Kaby-Lake X is just a regular old Kaby-Lake die, but on the X299 package, because X299 has a much better package for power delivery, which is why you get the better overclocking on Kaby-Lake X. The downside is the motherboards basically need to add extra components that are completely unnecessary for running Skylake X CPUs in the process. So, yeah, that's kind of less than ideal. Anyway, back to the VCCIN, or also known as vCore VRM. It's a 1, 2, 3, 4, 5, 6, 7, 8-phase setup. It is controlled by this chip right here, and that chip is a International Rectifier IR35201, running in 8-phase mode, so you do actually get a true 8-phase right here, and it goes from 200 kilohertz switching frequency all the way up to 2 megahertz, though International Rectifier power stages are typically optimized for 300 kilohertz switching frequency, so that's what I'm going to be doing all the calculations for this VRM with, and also what the board is probably running. I have no idea based on just pictures of the motherboard. Even if I had the board in hand, I'd probably end up having to use an oscilloscope to figure out what frequency it runs at. So let's talk about the power capabilities of this lovely thing. The power stages, which I've already mentioned, are these chips right here, and these are International Rectifier again, because you usually use the same brand power stage as controller manufacturer. These are IR3556s. These are 50 amp power stages, and unfortunately I cannot get a full public datasheet for these. So instead I'm using the International Rectifier 3551 datasheet, which is also a 50 amp power stage and the predecessor of the 3556. The main difference between sort of the newer generation of International Rectifier power stages like the 3556 here, compared to, say, its predecessor, the 3551, is the new generation of power stages is a lot more power efficient at higher switching frequencies. However, they are still optimized to run best at 300 kilohertz, whereas like the older ones would like get really inefficient as early as like 600 kilohertz, whereas you know, the newer ones could go up to 600 kilohertz before it gets really bad. So there's a small improvement in efficiencies. Well, there is a pretty significant improvement in efficiency at higher switching frequency, but ultimately most boards aren't going to run it because you get best efficiency at around 300 kilohertz. So that's what I'm doing all my calculations with. I'm also not going to do any calculations for Kaby-Lake X because it's just like, one, you shouldn't put Kaby-Lake X in this motherboard. Two, Kaby-Lake X is not concerning compared to Skylake X in terms of power consumption and current draws. So I'll just do all the Skylake X, we'll go through values for Skylake X, and you know, that's going to be the comparison point for motherboards, because Kaby-Lake X is just a lower load, really. It's just easier to run than Skylake X. So since we're going to be calculating for Skylake X, and I'm going to give you different power levels for different overclocks. So 150 watts, that is a 7900X at stock. 200 watts would be a very mild overclock. Mind you, these numbers are peak loads, or like Prime 95, or in one case Cinebench, because this board, we've run into some weird issues in testing with it, where you basically, like, you try to run Prime 95 AVX 512 on it, and the power draw ends up being lower than Cinebench at some point. So the board is obviously power throttle, like the CPU is obviously throttling, but there's no way to get rid of that. So yeah, that's a bit of an issue. Then 250 watts. So this is probably where most people will stop, between 250 and 300 watts. And the reason for that is past this point you need D-lids. Also exceeding this point, like, this is where we run into the power throttling, because basically we can't get the CPU to pull more than 200, like, we can get a stable overclock and usable overclock at 264 watts of power draw. So for the 7900X that we have here at Gamers Nexus, that was done at 4.5 gigahertz. 1.175 volts V-core. So yeah, and that's, you know, that's V-core, not VCCIN. That's a major distinction. So this is the voltage the CPU actually ends up, like, that's what the core, that's what comes out of the fiber. So the VCCIN goes into the fiber, this comes out of the fiber. Ultimately, what this VRM is seeing is not that. The VRM will see a constant 1.8 volts because it doesn't really seem to do anything to change VCCIN on Skylake X so far. And so all my ratings are also at 1.8 volts. So yeah, sort of this is where we maxed out. And another issue with this max out was beyond this, the CPU temperatures just go through through the roof. You very quickly end up hitting 90 plus degrees, 95 plus degrees under stress tests, which you can't do anything about. And now you may be thinking, oh, but I'll get a custom water loop and I'll totally get an even higher overclock. You won't, because unfortunately the thermal interface materials used on Skylake X is so bad, and that basically the water in the AIO that we used to do this overclock was really not that hot relative to how much, you know, relative to how much power the CPU was putting out. So that was with high RPM fans and everything, and basically the AIO radiator was pretty much cold and the CPU was cooking because the thermal interface material that Intel is using, or just the way it's applied, one of the two, is really, like, it's just blocking all heat transfer from the die to your cooling system. So a bigger cooling system won't help you because your bottleneck is the thermal paste under the IHS. So to exceed that 300 watts or 250 watts of power draw, you're going to need to delid your CPU. But if you do delid your CPU, it is completely possible to go as high as 400 watts, or if your cooling system is up to it, even 500 watts of power draw. So I will do, I've done calculations all the way up to there. I'm assuming that 1.8 volts for all of those figures. So the current levels for these different numbers are, you know, for 150 watts, you're looking at sort of 85 amps through the VRM. And I've just realized that I should have not put this right in the middle of my stuff, but oh well. 85 amps through the VRM, that would produce about 10 watts of heat, so not an issue. I don't know how the board will ultimately do in testing for VRM thermals, so I do not have the board, and it is impossible. Like, I can calculate how much heat the VRM will put out for a given amount of power that it needs to supply and current it needs to output, but I cannot tell you if the cooling system is good enough to actually deal with that. So yeah, but 150 watts, 1.8 volts, you'll get, you know, around 85 amps and 10 watts of heat off the VRM. 200 watts CPU power consumption, you're going to be looking at about 110 amps through the VRM, and that'll produce about 13 watts. So still really not, like, that should be non-issue. 250 watts, you're going to be looking at about 140 amps and about 16 watts of heat. So I still think this should be relatively not problematic, since you're only exceeding the stock heat output by, like, you know, 60%, which is a lot, but once we get into the bigger power numbers, you're going to see where the issues start showing up. 300 watts, you'll be looking at around 165 amps, also, which translates to about 21 watts of heat output on the VRM. 400 watts is 220 amps and 31 watts of heat. This is where I think you'll start seeing VRM thermal issues. And then we can keep going up, because it is still possible to push the power draw even higher. At 500 watts, 1.8 volts, the VRM will have to output about 280 amps of current and will produce about 47 watts of heat. That is a problem. That's like a low-end CPU worth of heat. That's like a laptop CPU's worth of heat output. So yeah, that is really hot. It will need a substantial heatsink. You'll probably even need to give it extra airflow if you have a cooling system sufficient to dissipate 500 watts of CPU power consumption, and as well as, you know, the delidded CPU, so that your cooling system can actually get to those 500 watts. because the thermal paste that comes on these CPUs stock will definitely stop you from actually getting anywhere near that before the CPU basically thermal throttles. So, yeah, that's the sort of VRM situation. I don't really see it as a, I don't really see it as a huge problem because we've not, Steve hasn't managed to get the board to give the CPU more than 264 watts of power. And at that kind of power draw level, you're looking at between 16 and 21 watts of heat, which even an anemic and kind of badly designed VRM heatsink shouldn't really have a problem with. But if you do delid, you might run into serious issues because that's a lot of heat output. Now, just for the sake of comparison, I've gone ahead and also calculated what the 220 amps would do on a Z270 Gaming 9, because that's like the same class of motherboard as this. I know it's on a different chipset, but it's the same sort of target. And so I've calculated the Z270 Gaming 9, and it's 16-phase VRM, except that is using International Rectifier 3553 power stages, which I do have a public datasheet for, so that's great. And interestingly enough, that 16-phase using the 3553 power stages, which are 40 amps instead of 50 amps, produces the exact same amount of heat as this one does for 220 amps of power consumption. I mean, current draw at 1.8 volts, 300 kilohertz switching frequency. So that actually really surprised me because I was kind of hoping, there are still some motherboards on mainstream Intel platforms where the VRM is actually better than what you find on a lot of X299 motherboards. But at least there's no recent examples of that, so I don't know if that means quality has just gone downhill across the board, or if, I guess you could say quality has just gone downhill across the board, couldn't you? Because there's no real reason to not give a super high-end platform a super high-end VRM. I mean, this is definitely sufficient, and, one of the major issues with X299 VRM design is the fact that you need to somehow fit the VRM between the two banks of 4 memory slots, but this could be stronger. It's not a problem for even on a 7900X and normal overclocking. You shouldn't run into issues. If you delid, if you somehow manage to circumvent all the power throttling stuff, yeah, you can definitely get the VRM to overheat, because then your power consumption will get kind of silly. Your current draw will go way up, and the VRM heat output will go through the roof. But for normal day-to-day overclocking, I don't really see a problem with the VRM here. So yeah, I mean, that's not really a good thing to say about a top-of-the-line board, in my opinion, because this is the Gaming 9, so it should be held to higher standards. But well, it is what it is. I'll let you pass your own judgment on this. I'm just the messenger. Anyway, let's move on to all the other minor VRMs on the board. So starting off with the VCCA right here, which it just conveniently happens to be there. And now I'm starting to think this might not be VCCIO. Nah, that's got to be VCCIO. Anyway, so this is VCCSA. And that's a single phase controlled by this chip right here. And that is an IR35204. That is a 4-phase voltage controller. I have not written it down. Anyway, it runs in 1-phase mode here anyway, so it's not a problem. I have the important part. It's running in 1-phase mode, and it's controlling an International Rectifier IR power stage again, and that is a IR3553. So that's that 40 amp power stage, which this is just ridiculous overkill for VCCSA. This VRM is only ever used on KB. Like on a lot of motherboards, sort of from KB, you'd see a VRM like half as big or even a quarter of what this is for VCCSA. So 40 amp power stage IR3553, absolutely not an issue. Massive overkill there. I don't have any complaints, and I just realized that goes over another VRM that we're going to be talking about, the memory VRM located right over here. So this provides your DDR4 with power, and it's a 2-phase, again using the same IR that. And it's also using IR3553 power stages again. In fact, basically every single one of the minor VRMs on this board is also a 3553. That there is a 3553, that's a 3553, that's a 3553, that and that is also a 3553. This voltage controller up here is yet another IR35204. This set of phases over here is memory again, so basically here they put them in a corner and next to each other. Here they put them, you know, behind each other and sort of to the left of the memory slots. So that's your memory power there. Both of these are two-phase VRMs. Both of them are controlled by the same 35204 voltage controller. Both of them are completely ridiculous overkill for DDR4. So that's nice. I'm guessing what happened is Gigabyte got like Infineon started giving away IR3553s to Gigabyte for free or something, because I've seen a lot of Gigabyte boards and there's just IR3553s everywhere. And I've just kind of noticed from a few boards I've looked over recently, and it's just, if it's a VRM, it's probably using a 3553, which, you know, that's nice because you get a lot of ridiculous overkill in places, but on the other hand, it's a bit wasteful maybe. I guess it does make the bill of materials a lot simpler though, so that's nice. Let's move on to the other remaining VRMs. There's the VCCIO, which is basically similar to the VCCSA. That's your system agent. That's basically the memory system and PCIe, and that's the other part of the memory system and PCIe. These voltages affect memory overclocking, and if you're running a lot of GPUs, they would also affect that. But basically, you don't have to worry about voltage regulation on those. They're very low power. It's just a case of like, yeah, they exist. Moving on, the other minor rail, these guys right here, those are both VPP. I cannot find the voltage controller for them, and VPP is the, that's a supporting voltage for your DDR4 memory sticks. This is a power rail that was so small that it used to be integrated into DDR3 sticks. Like, this voltage didn't exist on DDR3 because DDR3 produced this voltage on the memory sticks themselves. So this is a very, very low power VRM, and the use of the IR3553 on these is just even more ridiculous overkill than the use of IR3553s anywhere else on this board. So, yeah. I'm 99% sure Gigabyte just has a warehouse full of these and they don't know what to do with them anymore because they're putting them everywhere, which, you know, that's a good thing, but I guess VCore VRM could be better. So, yeah, that pretty much wraps it up for VRMs on this board. There's nothing left I can still cover here. But memory power, definitely just fine. VCCSA, VCCIO are just fine. There's no issues with those. VCCIN/VCore. It could be bigger. It probably should be bigger. For one thing, the 3556 is not the most powerful power stage that would fit into this package right here. Like, I mean, the actual physical board space, because that's the main constraint with X299. You need to fit your VRM into a very small, relatively small footprint. The thing is, International Rectifier makes a 60 amp power stage that fits basically in the exact same amount of space as a 3556. So using the 3556 instead of the 3555 is almost entirely a cost-saving measure from Gigabyte. Because the 3555 would actually get you better VRM efficiency. But yeah, that's kind of a thing. Ultimately, it's not like the VRM is going to blow up on you. It might get really hot if you get past the cooling restrictions of Skylake X. But if you're doing just day-to-day overclocking, it's not going to be an issue. Now, I guess if you're doing day-to-day overclocking, well, ultimately, this board has features that I just don't care about, so I'm not going to talk about the merits of the rest of this motherboard. But yeah, the VRM for VCore, VCCIN, I'm not impressed. The memory VRMs, I have no complaints. All the supporting voltages, really, I have no complaints. VCore, VCCIN could definitely be stronger, but, you know, it's not like it's going to burn your house down. So that's it for this video. Like, share, comment, subscribe. Also, please support Gamers Nexus on Patreon. If you would like to see more videos like this, you can head over to my channel called Actually Hardcore Overclocking, where I do PCB breakdowns like this one, as well as lots of other overclocking related videos. Thank you for watching, and see you next time.